Your app database is doing something weird. The database is on a private subnet, exactly where it belongs. Security groups say no public inbound 5432. The only path in is SSH to a bastion. The bad fix is opening the database to your office IP, then forgetting the rule exists. The clean fix is SSH local port forwarding. You make a port on your laptop, connect your normal tool to localhost, and SSH carries that connection to the private service. Same database, same credentials, no public database listener. SSH local port forwarding is the -L tunnel. It pulls a service that is reachable from the SSH server side back to your own machine. The classic shape is SSH-L 8080:target:80 bastion. After that, your browser opens localhost port 8080, and the bastion connects to target port 80 from its side of the network. This exists so administrators can reach private admin interfaces, databases, metrics pages, and one-off maintenance endpoints without publishing them to the internet. The tunnel inherits SSH authentication, keys, MFA, certificates, account policy, logging, and whatever access controls protect that SSH login. Think of this in two halves. The local half is a listening socket on your workstation. If you bind 127.0.0.1 port 8080, only processes on your workstation can connect to it. The remote half happens after traffic enters SSH. The SSHD on Bastion opens a TCP connection to target port 80, as seen from Bastion. That detail matters. Target names are resolved on the server side, not on your laptop. If DB01 only exists in private DNS, that is fine as long as Bastion can resolve it. SSH encrypts the traffic between your client and Bastion. From Bastion to target, the original service protocol applies. Here are the exact lines. The first command starts SSH without running a remote shell because of -N. The -L argument has three parts after the optional bind address: local port, target host, and target port. I wrote 127.0.0.1 explicitly, so the listener stays on loopback. Local port 8080 is what your laptop opens. Target:80 is what Bastion fetches. The final word, bastion, is the SSH host from your config or DNS. The second command is the database version. Local 5432 goes through SSH, and the bastion connects to DB-01 port 5432. Now use it end to end. You administer a production Postgres server named DB-01. It accepts connections only from the private network. Your bastion can reach it, and your workstation can SSH to the bastion. In Terminal 1, start the tunnel shown on screen. Leave it running. In Terminal 2, run psql against 127.0.0.1 port 5432. psql thinks the database is local, but SSH is carrying the TCP stream to Bastion, and Bastion is connecting to DB-01. Database authentication still happens at Postgres. SSH gets you to the network location. It does not replace database users, passwords, certificates, or row permissions. The first mistake is binding the tunnel to every interface. If you use 0.0.0.0, coworkers, malware, or anyone on the same network may be able to use your tunnel, depending on host firewall rules. Use 127.0.0.1 unless you intentionally need a shared listener. Second, know that SSH authenticates the tunnel, but it does not magically authorize the target application. The database or dashboard still needs its own access controls. Third, use ExitOnForwardFailure when scripting, so SSH exits if it cannot bind the local port. On servers you operate, control this with SSHD config options, like allow TCP forwarding and permit open when users should only reach approved destinations. Local forwarding is one member of the SSH forwarding family. -L pulls a remote side service to your local machine. -R, remote forwarding, does the reverse. It makes something near you appear on the remote side. -D creates a SOCKS proxy, useful when the target changes per request. Proxy jump -J solves how you reach the SSH server in the first place. In the practitioner tier, the point is choosing the smallest tunnel that matches the job. For one database or one dashboard, -L is usually cleaner than a VPN and safer than opening an inbound firewall rule for a temporary task. Practice this on a machine you own or a VM where SSH to localhost works. In Terminal 1, Start the Python web server bound to 127.0.0.1 port 8000. In Terminal 2, start the SSH tunnel to localhost, mapping local port 188080 to remote side 127.0.0.1 port 8000. In Terminal 3, curl 127.0.0.1 port 188080. You should see the directory listing from the Python server. Then stop the tunnel with Ctrl-C and run the curl again. It should fail. That proves the listener was created by SSH, and the service was only reachable through the tunnel. 3 beats to keep. First, SSH-L creates a listener on your machine and forwards accepted connections through SSH. Second, the SSH server connects to the target from its side, so names, routes, and firewall rules are evaluated there. Third, bind to 127.0.0.1 unless you have a deliberate reason not to, and remember that application authentication still matters. That is SSH local port forwarding, the database and dashboard pattern without exposing private services. Tomorrow, we keep building this practitioner toolkit. New SSH Mastery episode daily on this channel, and the daily ranked CVE brief is linked in the description.